Hello. In an earlier video, I was showing you how we can use some pie charts to find out approximately how much energy is stored in different modes in gravitational potential energy and kinetic energy at these different spots in the graph. And then we found the gravitational potential energy that was in part in spot D. Okay. But now I want to also know how much energy is in the other spots. And so we're going to look at part A, part B, and part C. Well, let's look at part A here and compare that pi to the one at the start. At the start, the person had, at point D, the person had a whole pi of gravitational potential energy. Now at point A, they have no gravitational potential energy because they have no height, but they have kinetic energy now. And those pi's must be the same size because of the law of conservation energy telling us that we never gain or lose energy. All right, that means pi 2 kinetic energy must be 6,000 Newton meters, just like it was at the start. So that one's pretty simple if we use our pi's. Always want to use your pi's. Well, then let's look at the third pi. How much gravitational potential energy is going to be there and how much kinetic energy is going to be there? Well, again, we made this pi half and half. We showed that the kinetic energy or the gravitational potential energy was half of what it was at the start because the height was half what it was at the start. And gravitational or potential energy depends on height. And so, since we know it's half, half of what? Well, half of the 6,000 Newton meters that it was at the start. Half of 6,000 is 300. So, gravitational potential energy here at point B is going to be 3,000 Newton meters. But the other half of the pi is kinetic energy. And that must be 3,000 Newton meters also, then, at that spot. Okay, so we're going to write that. And finally, our last spot is just a little bit harder, part C, because it's 2.2 meters and we don't know exactly how that number compares to 10. All right. So I'm going to start out and I'm going to go ahead and write my 6,000 Newton meters for my gravitational potential energy at the start. But I do know how the gravitational potential energy at C compares to the start. 2.2 meters, it's going to have 2.2 meters worth of gravitational potential energy compared to 10 meters here. Okay, so I know I need to make that smaller. I know my 6,000 Newton meters is going to be smaller to get the amount of gravitational potential energy at C. So I'm going to use that ratio, 2.2 meters to 10 meters. And now I'm going to grab a calculator because I forgot to do that before I started to make the video. And so I'm going to grab a calculator and I'm going to do this math. It's going to be 6,000 Newton meters times 2.2 divided or equals, and then divided by 10 and equals again. And that's 1,320 Newton meters of gravitational potential energy at the end or at part C. Okay. It's quite a bit less than 6,000, of course, because we only got 2.2 meters high. Now, how much kinetic energy is going to be there? Well, I started with 6,000 and of Newton meters of potential energy. Now there's 1,320 left. The rest of it has gone into the speed of the skateboarder. The rest is kinetic energy. We can see that in our pi that the rest is kinetic energy. So if I take 6,000 Newton meters and I subtract 1,320 Newton meters, I should be able to get my kinetic energy. And so that is 6,000 minus 1,320 equals 4,680 Newton meters of kinetic energy. So you can see we can find out how much kinetic energy and potential energy there are at each spot in this roller coaster ride or this skateboard ride just by using the gravitational potential energy that we have at the very start.